Thank you, Dr. Hedengren, for your generous sponsorship of our research. Our goal is to make this technology available to Jawas everywhere. We have been acquainted with this problem for several years, and until now we haven't had an opportunity to explore one of the more poignant problems facing Jawa society. The abandoned Corellia Mining Corporation Sandcrawlers are an integral part of Jawa life. These sandcrawlers provide mobility, income through trade, and a home for the majority of Jawas. But because the sandcrawlers were designed for a 2-meter tall operator, the Jawas, who measure 1 meter on average, cannot adapt to the controls and have asked us to remedy the situation. Our objective was to design a system that would maintain a constant speed set by a Jawa operator and control the sandcrawler on hills and canyons safely. And that is what we did.
Our model is based on a momentum balance, which simplifies to include the forward force provided by the engine, the force of gravity weighing on the vehicle, and the drag force, which incorporates an estimated wind resistance and internal friction. The assumptions involved turned out to be fairly heavy. First, we assume that the mass of the crawler is significant enough that the energy required to rotate the drive wheel and tracks is negligible compared to the energy required to move the crawler, so only linear translations were taken into account. After spending multiple hours with no success on simulating due to numerical solving issues, we also assume the static friction of the terrain is strong enough to support the force produced by the engine over the entire range of power and slopes. Our control system utilizes cascade control, with the master controller controlling the velocity and manipulating force. The slave controller controls the force and manipulates the power output.
Tatooine has a very dynamic topography. It is paramount, therefore, that our speed controller be able to respond accurately to changes in the terrain. We simulated the Sandcrawler's response to changes in slope gradient using the aforementioned closed-loop cascade controller. Using this model, we performed several tests and designed a master and a slave controller to respond in a safe and effective manner. To give you an idea of our controller's performance, we will expound on the following example. We gave the Sandcrawler a set point of 5 meters per second and asked the Sandcrawler to climb 2 very large hills in series. Here is how the Sandcrawler responded. As you would imagine, the velocity of the Sandcrawler plummets when it hits the hill. The engine responds by inputting a greater force to compensate. While doing so, the controller is designed to minimize overshoot and maximize the life of the Sandcrawler's engine.
We estimate that if our control is implemented with our tested parameters, Jawas can confidently use the system safely. Our parameters are calculated not only to be safer for the Jawas, but will increase the Sandcrawler's engine life by avoiding needless overshoot. In all of this, Jawa operator and passenger safety is our #1 priority. In our research, we have become more acquainted with the Jawas, and we know that life is not easy for them. So, in this small way, we are proud to provide an improvement in the Jawas' quality of life.